So this is cooperation part 3. Let's get to our PowerPoint slide. So we're looking at the mechanisms of the evolution of cooperation in animals. How does cooperation evolve in animals? And we looked at byproduct mutualism. Now we'll take a look at reciprocal altruism or reciprocity. And this is a huge category and was first written about carefully in the 1970s by Trivers. So the definition of reciprocal altruism or reciprocity is animals will cooperate now if the cooperation is paid back later. I'll scratch your back if you scratch mine later, right? I'll cooperate now. I plan on you cooperating with me later. Tit for tat type of strategy almost, right? And we know that this happens all the time in animals of all different kinds of species. So we're going to give you some examples. This is also looked at pretty carefully in our Simutext assignment on cooperation. And so some of the examples you see here might be some of the things you'll see in that assignment. So under what conditions would selection favor the evolution of reciprocity? When would reciprocity be likely to evolve? What kinds of things would have to be true in a population of animals? Well, I think animals would have to live in a group. You aren't going to cooperate, obviously, if you're by yourself, living by yourself. So you need to live in a group, and you need to regularly interact with the same individuals in the group. You can't live in such a huge group that you never pay any attention to anyone else around you. So we need to have a group in which you regularly interact with the same partners or the same individuals. Maybe they're rivals in a nearby territory. Maybe they're your partner in reproduction, whatever, right? And number 2, animals will have to be able to recognize each other. Oh, yeah, you're my neighbor. And remember acts from the past. Oh, you're my neighbor, and you're the one that screwed me over last week, right? So animals have to be able to recognize each other and remember acts from the past. Is this likely? Absolutely. Animals are wicked smart. They do have memories for this, all right? Now, how do we go about studying reciprocity? Researchers have used game theory, and we talked about that before, but it's this mathematical model, right, used to predict behavior. When an individual's payoff, like in terms of resources gained, food gained, mating opportunities gained, when an individual's payoff depends upon what other animals are doing, how other animals are behaving, right? And there's one particular game called the Prisoner's Dilemma that helps us to understand why reciprocal altruism evolved or cooperation evolved in this method. It's called the Prisoner's Dilemma because the researchers who came up with it started with a prisoner problem, if you will. It's a model to understand the evolution of cooperation or reciprocity. And here's the basic problem. You've got these 2 people and they committed a crime. And they agreed, hey, let's not tattle on each other. So they agreed to cooperate, staying quiet if they got caught, all right? And of course they got caught. The police bring them in and talk to each of them separately, question each of them separately. And the police say, hey, if you implicate your partner, you can go free. So there's a temptation to defect, to say, I didn't do it, but he did it, right? That would be defecting, and that would be blaming the other person. And the question is now, what do you do? Do you cooperate and stay quiet, or do you blame the other person? Well, let's think about the behavioral options for each player and the potential payoffs for each player. So we're going to make this nice box, and we have to add a few things in here, I think. All right, so in this picture, we've got player 1 over here and player 2 up on the top, and we're going to follow the payoffs for player 1. So you have 2 options, as each player does. You can either cooperate, which means, hey, I'm not going to say anything. I'm not going to accuse anyone. I'm not going to say much. Or you can defect and say, that guy did it, right? And so there's kind of 4 different situations. If player 1 cooperates, player 2 might cooperate or might defect. All right. So if both players cooperate and don't implicate each other, there's a reward for that. Let's just say, let's just make up some numbers here. They're kind of important though. The reward is only 1 year in jail. The police are like, yeah, but we know you did it. We have some evidence. So each of you are going to get 1 year in jail. Okay? That's bad, but not too bad. Is a player 1 could defect while player 2 cooperates. Okay? There's a temptation to say, player 2 is like, yeah, nope, we didn't do it. And player 1's like, yeah, player 2 did it. There's a temptation to defect. And that's great because if you defect and your partner cooperates, then you don't get any years in jail. You're good, man. On the other hand, let's just say you're player 1 and you cooperate, but your partner defects. You're like, oh, no, we didn't do it. But your partner's like, he did it. That's called the sucker's payoff. You cooperate, but your partner doesn't. You get 5 years in jail. That's bad. And there's the other situation, the punishment for mutual defection, if you will. You defect, you say, he didn't do it, I didn't do it, he did. The other partner goes, yeah, I didn't do it, he did. And the police are like, wait a minute, you both were implicated. There's a punishment for that. We're going to call it 3 years in jail. Okay? When you get a situation like this, there's a clear strategy to defect, right? It's clear that defecting is your best option because if you defect and your partner cooperates, you get 0 years in jail versus if you cooperate, you get 1 year in jail. So defecting is better than cooperating when your partner cooperates. Is defecting better than cooperating when your partner defects? Yeah. 3 years in jail is better than 5 years in jail. Okay. So when the payoffs go something like this, when the temptation to defect payoff is greater than the reward for cooperating, and that's greater than the punishment for both defecting, and that's greater than the sucker's payoff, then your best strategy is going to defect no matter what your partner does. You know, you're still going to do better, right? This doesn't seem like a good model for the evolution of cooperation. Why would you ever cooperate then? You would cooperate if the game goes on. If the game goes on, it's better off in the long run. Look at all the rewards. It's better off in the long run to cooperate if you're going to see each other again, because if you cooperate, you won't experience the sucker's payoff or the punishment for mutual defection if your partner also cooperates, right? So the best strategy might be to mutually cooperate if we're going to interact again and again and again. If we're going to help each other defend our territories against a predator again and again and again and again, it might be better to cooperate. The payoff for both cooperating is better than the payoff when your partner defects all the time. Okay? So, by the way, this is called the prisoner's dilemma because the best strategy, if it's only happening once, is to defect, right? But the best short-term strategy. But if you both had cooperated, then you would get kind of the second best situation, right? So it's a dilemma. What does the prisoner do? Does the prisoner defect or does the prisoner cooperate? But what we're saying is if this happens again and again and again, the best strategy would be for both players to cooperate because the overall payoff will be better than if your partner defects on you. So researchers came up with this, what's called the iterated or repeated prisoner's dilemma game. Axelrod and Hamilton in 1981 said, hey, this is probably how cooperation could evolve by reciprocal altruism. We call it the tit-for-tat strategy. one's solution to the iterated prisoner's dilemma. So if you see this partner again and again, and you have decisions to make, and you remember what this partner did last time, you can follow a strategy that might benefit you the most, and it might involve primarily cooperation. And here's the strategy, or here are the rules to the game, if you will. I'm going to write them down. There's 2 rules. They're super simple. Be nice on the first encounter. Cooperate on the first encounter. Be nice. Cooperate on the first encounter. Okay? Whenever you see somebody, you're going to help them out the first time. And then, from then on, the individual copies the previous partner's behavior. What that means is you cooperate if your partner just cooperated, or you defect if your partner defected last time. So you copy partner's behavior. So if your partner last time cooperated, you keep cooperating. If your partner last time defected, you defect. Okay? There are 3 characteristics of this tit-for-tat strategy. 1, be nice, don't cheat first. 2, retaliate. If your partner cheated last time, then it's time to retaliate. And 3, be forgiving. But if your partner, okay, so you're seeing this partner multiple times. If the last time your partner cooperated and helped out with nest defense or with territory defense or gave you food or whatever, then forgive and go ahead and cooperate again. This leads to cooperation. Regular cooperation between individuals who recognize each other and individuals who remember their past encounters. And this seems to work in a lot of animals. This simple tit-for-tat strategy. Be nice the first time I see you and copy my partner's behavior, my partner's previous behavior, the next time I encounter you. And that seems to be a strategy that works, and it leads to the evolution of cooperation. So let's see. By the way, this strategy works, or this tit-for-tat strategy works as a prisoner's dilemma game only if the temptation to defect is the payoff for defecting is greater than the reward, is greater than the punishment, is greater than the sucker's payoff, so that we get that same chain, if you will, of payoffs. So now let's give you an example. Let's look at some examples of research that have been done to look at cooperation in real populations. And this example I love just because it's so much fun. Sea basses are a fish that practice what's called synchronous hermaphroditism. That's a hard word to say. Being hermaphrodite means that you have the ability to make eggs and make sperm. A synchronous hermaphrodite has the ability to make eggs and sperm at the same time. So a sea bass has a testes that make sperm and ovaries that make eggs, and they're functioning at the same time. So they can make eggs, they can make sperm. Okay. And they encounter each other and mate with each other. So they don't fertilize they don't use their own sperm to fertilize their eggs. They actually encounter another sea bass and essentially swap sperm. But it's a complicated relationship. What happens in the sea bass is something that we see in a lot of fish. You've got 2 animals swimming up to each other. One of them is going to take on the role of the male, and one is going to take on the role of the female initially. And so they'll do this little courtship dance where one of them acts like a male and does certain things, and one acts like the female. Then the female will lay her a little bunch of eggs, and the male will fertilize them. And then in this same partnership, the sea bass that was acting as the female will then switch roles and will start acting as the male, and the fish that was acting as the male will switch roles and start acting as the female. And they'll do this little dance, and then the fish will drop its eggs, and the new male will fertilize its eggs. And then they'll do this again and again. What happens essentially is each animal parcels out a little bit of eggs, and the other individual fertilizes those eggs, and then they switch roles. And eventually all of the eggs that each of the fish has are fertilized. That's in the best situation. It turns out that eggs are very expensive to produce relative to sperm. Sperm are like a dime a dozen, okay? You can produce a lot of sperm for very little cost, but eggs cost a lot to get ready. And so there's this temptation when two sea basses come together to simply produce sperm. Why bother producing eggs if your partner will produce eggs and you can fertilize them with your cheapo sperm? There's a temptation to not cooperate and not produce eggs. There's a temptation to only produce sperm. So let's take a look at the payoffs, if you will. Let's just say we've got player 1 and player 2, and they come together, and we've got player 1 as the egg initiator for now. So that player is going to play the role of female at first. Okay, and so if they cooperate, if player 1 cooperates, this fish lays eggs, then player 2 cooperates and fertilizes those eggs, but then turns around and lays eggs itself so that player 1 can fertilize them. That's called cooperation. That's a good thing, and it can lead to all the eggs from both of the animals being fertilized. Player 1 could defect. Player 1 could not even lay eggs to begin with. Player 1 has the temptation to just be like, I'm going to let you lay eggs first, and I'm going to lay my sperm, and then I'm out of here. That's rewarding because you put no effort in some ways. You put in very little energy into making sperm, and you get your player 2 kind of is being suckered, right? Player 2 is getting the sucker's payoff. I've laid some eggs, but the other partner left me, if you will. Okay. If player 1 cooperates, and player 2 doesn't, then player 1 gets the sucker's payoff. So player 1 lays the eggs, and player 2 fertilizes those eggs, but then player 2 leaves. Poor player 1. Player 1 can't fertilize any eggs then. And then, of course, there's the situation of mutual defection. Neither of them decide to lay eggs at all, and nobody's eggs get fertilized, but you haven't put in a huge energy investment either. So there's punishment for mutual defection, but it's probably not as big as the sucker's payoff. The sucker's payoff sucks, basically, right? What do these animals do? Do these animals live in groups so that they can recognize each other and interact again and again? And do they follow the rules of tit-for-tat strategy? Well, researchers have been looking at that, and guess what? They've found that fish do follow the tit-for-tat strategy. The simple, be nice the first time, and then every time after that, follow what your partner has done. So it turns out if a fish meets up with another fish who has previously cheated, only parceled out sperm, then the first player is much, much less likely to lay eggs at all, and much slower at laying them. They know and can recognize that partner who defected on them last time and are much less likely to cooperate the next time. This is a really cool problem that researchers are studying. And it's amazing that fish can recognize each other and recognize and remember who has cheated in the past and pay attention to it. And it's a simple strategy. It works. It leads to the evolution of cooperation most of the time. Pays off to cooperate most of the time, right? But it can also lead to cheating. And cheaters are out there. So it's kind of an interesting strategy. Here's another example. Adult vampire bats. This is one that our assignment goes into a lot of detail on. I just find these really cool. They're called Desmodus rotundus, these vampire bats, and they live in social groups of 8 to 12 members. And what happens is they go out each night and find a blood meal and use that blood meal to survive until the next night, and then they go out again and get another blood meal, etc. And it turns out that they're not always successful at getting a meal. About 80%, About 8% of the bats fail to find food during a single night. And it turns out that bats can starve without food in about 48 to 72 hours. So 2 to 3 days. If you fail a couple nights in a row, you're in real trouble. But it turns out that bats in these small groups will regurgitate blood meals and share their food with other bats in their group. Typically, the regurgitation happens from female to female, but from what I understand, it can go from female to male to female, male to male too. So they share food. They cooperate. Why do they share food? Why do they cooperate? This could be an example of reciprocal altruism using a tit-for-tat strategy. And researchers are showing that that's exactly what it is. Okay? Why do these bats share their food? Well, they have the ability to detect cheaters because they can recognize individuals. They're good at recognizing individuals, and they can remember what happened in the past. They have a high probability of reciprocation in the future. They have repeated opportunities for interactions in the future. So every single night they come back to their little social group. They know each other. They see each other. They're right next to each other. And this happens night after night after night after night. So this would be a place in which reciprocal altruism would be likely to evolve, right? And there are large benefits to the recipient, okay? It pays to cooperate. You are much more likely to survive if you get a blood meal when you haven't gotten a meal. And the cost to the donor. It turns out if you give a blood meal, if you share a blood meal, it's not super costly. If you share that blood meal, it's going to lower your survival rate, but barely at all. And so it's not super costly to share. So it's not a huge sucker's payout, if you will. I think the sucker's payoff, if you share and your partner defects next time, it's not going to cause you to die. On the other hand, it pays off in the long run to reciprocate because, upward of close to 10% of the nights, every couple of weeks, you're probably not going to get a blood meal, and you're going to need somebody to share with you. And so researchers look into, have studied this and think, yeah, this is a really good example of animals using a tit-for-tat strategy and cooperating because it pays off to cooperate. It's the best strategy. What about humans and reciprocal altruism? There's certainly a universal need to cooperate with others. And if we look at, say, traditional societies, and we look at food sharing definitely happened in traditional societies. So if you have a large kill, you kill a large animal and your family can't consume it all, the hunter typically shares the meat with others in the group. Okay, why share? Why bother sharing? Well, here's why. There's an expectation of returning, of reciprocation in the future. When I don't get a meal, when my family is suffering, and you hunt down a big animal, then you're going to share with me. That reciprocal altruism or reciprocity is important. You're in a small group. You obviously remember what's happened in the past. You interact with these individuals all the time, day in, day out. Plus, there's a small cost of sharing, and the sucker's payoff is pretty small because food's going to go bad anyway, and you've already done the hard work and gotten the animal. You've done the hunting, and so there's really a small cost. Others benefit and will return the favor in the future. And this is looks like a very common way in which reciprocity evolved in humans. Okay, we also find that reciprocity is more likely in a sedentary population than in a transient one. So if you've got a population of people in which they're always coming and going, and there's new members entering the population and then leaving the population, they're much less likely to engage in this kind of reciprocity than if you're in a small, stable population in which everyone knows each other and they interact with each other all the time. Also, it does kind of pay off to cheat. Every once in a while, it pays off to be a cheater, right? The temptation to defect is usually the biggest reward. But if you look at human populations over time, there's typically a very elaborate set of punishments for cheating. Intricate rules, they might be couched in religious language, but there are rules for to punish cheaters, because cheating messes with the whole system, right? Cheaters will benefit on a short-term level, but they can't, it can't work very well for very long. So, okay, that's the end of reciprocal altruism. You'll learn more about that as you do the cooperation assignment on Simutext, and we'll take a look at these two other strategies in the next video.